So in this example, we're going to take our idea of average and instantaneous speed and look at those in terms of this function here. So we are going to suppose that an object's position in feet is given by the function f of t equals negative 16 t squared plus 70 t minus 12. Okay. And we can see from these units here on these t values that t is in seconds. So position in feet, time t in seconds. All right, in part A, we are going to calculate an average speed for our object between t1 equals 1 second and t2 equals 3 seconds. Okay. So as we saw in the previous video, our average speed is calculated by taking the distance traveled and dividing by the time elapsed. So that is what we're going to do here. Now, when we've got a function like this, you might see that average speed formula written a little bit differently. So we can also write average speed. Instead of literally writing the word distance traveled, we can calculate that distance traveled by taking the difference between the two positions at those 2 points in time. So we could take the position f at time t2, subtract where the object was to start, so the position f at time t1. So f of t2, ending position, minus f of t1, starting position. So that is effectively the change in position or the distance traveled there. And then we're going to divide that by time elapsed. So that is the difference between your two times. So you can take time 2 minus time 1. Okay. And if you switch the order of those around, t1 minus t2, you just need to be consistent up in the numerator as well. Yeah, but we tend to calculate t2 minus t1 that way. All right, so plugging in our t2 and t1 values, this is going to be f of 3 minus f of 1 over 3 minus 1. Okay, I'll do the denominator. There we go. And then to calculate the numerator, remember you're going to need to plug in those values for t into the original function up here. So f of 3, you'd have to plug in 3 into all those t spots. Hopefully this is a very familiar process to you as you've been through algebra. When you do that calculation, you should end up getting a position of 54 feet. All right. And then you would do a very, very similar type of thing. You would plug in t equals 1. That one's a little easier to calculate. And when you plug in t equals 1, you should get a position of 42. So our numerator would be 54 minus 42 divided by 2, denominator there. And so we would end up getting an average speed of 6 feet per second. Okay, so there's our average speed between those 2 points in time, between 1 second and 3 seconds. Our average speed for this moving object was 6 feet per second. But just like we saw with the example in the previous video, traveling 3 miles in 15 minutes, your average speed is not always the same as your instantaneous speeds in that time interval. So even though the speed averages out to 6 feet per second, within that time period, 1 second to 3 seconds, this object could have been traveling at very different speeds. It's just that 6 feet per second is the average of those. So that's what we're going to look at in this next part here. We're going to find the average speed of the object now between t1 equals 1 second, like before, but now t2 is going to be 1.5 seconds. So, calculating our average speed now, it still uses the exact same formula, f of t2 minus f of t1 over t2 minus t1. But now we have a new t2 value. So it's going to be f of 1.5 minus f of 1 over 1.5 minus 1. All right. And so you'd have to plug in t equals 1.5 back into that function. Feel free to use your calculator on that if you'd like. Should end up getting 57. F of 1 we already calculated for the previous part. That was 42. And then we're going to be dividing by 0.5 in the denominator. So 15 over 0.5 is going to end up giving us an average speed of 30 feet per second now. So the average speed is pretty different over these two different time intervals. Over these 2 seconds in part A, we were traveling at an average of 6 feet per second. Over this half a second interval down here in part B, our object is traveling at an average of 30 feet per second, so way faster. And this is the same object, so during that first half second included in this interval, the object was moving a lot faster. Interesting. Okay, so what are we going to do about this? We've got two different average speeds, but what can we do if we want to estimate the instantaneous speed of the object at t equals 1 second? Well, can kind of see a little bit of a pattern here. We're bringing that second time mark closer to 1 second. So we've made a smaller interval of time from part A to part B there. That's what we're going to keep doing to try and find our instantaneous speed, or at least to estimate the instantaneous speed of the object. We are going to take smaller and smaller time intervals. Okay, getting closer and closer to the time that we're interested in. So we're going to be narrowing in our intervals here. Narrowing in on t equals 1 second. Okay, so you might kind of picture a number line here. There's the point in time that we're interested in, t equals 1 second. We want this guy, instantaneous speed right there. And so what we've done just in the first two parts of this problem was we took our time interval from going like this, 1 second to 3 seconds and finding the average speed, to narrowing down to go like this from 1 to 1.5 seconds. So we're getting a smaller interval to see what the speed looks like in that interval. So you can imagine if we took an even closer interval, an even closer interval, even closer, we're getting a very, very short time interval that brings us very, very close to what is actually happening at t equals 1 second. Okay, so that's what we're going to do here in this next part of the problem. All right, you're going to find the average speed between t1 and t2. And t1 is staying the same the whole time. It's still just t1 equals 1. But t2 is changing and nipping in closer and closer to t equals 1 second. Okay, we're going from t2 equals 1.1 to 1.01 to 1.001. So effectively, we're doing like this. We're bringing that second time closer and closer to the point that we're actually interested in. All right, so let's calculate these. Now, you might want to pause this video right here for a second so you can practice doing the average speed calculations. So go ahead and pause. But I'm going to keep rolling in the background here so that when you start this again, you can see the right answers. Okay, so our average speed, remember, we're doing f of t2 minus f of t1 over t2 minus t1 on all of these. Okay, so this would be f of 1.1 minus f of 1 over 1.1 minus 1. All right. And definitely feel free to use your calculators. That'll be about 45.64 minus 42 over 0.1. And so for this first one, we get an average speed of about 36.4 feet per second. Okay. Now the next two are going to proceed very, very similarly. So not a whole lot changing here with the process. Any errors you come across here are probably just something happening with your calculator entry. So if you don't get the same value, you might want to check how you typed things in. Here's our second time interval from 1 second to 1.01 seconds. Here you should get an average speed of about 37.8 feet per second. Okay. And now we'll do the last one, in which we have a very, very small time interval here. It's only 0.001 seconds. That would be, what, 1,000th of a second, a millisecond. That's pretty darn small. All right, so you'd put these in, get your values, and you should turn out to get an average speed of about 38.0 feet per second. Okay, now if you'd like, you can bring this T2 in even closer to 1 second. So you might just keep adding some zeros in there, like let's say if you wanted to try 1.0001, if you want to calculate that. Notice that if you do that, it actually turns out to still be about 38.0 feet per second. So it's kind of interesting. We keep making that time interval smaller and smaller, narrowing in on our point of interest at 1 second. And the speeds, the average speeds kind of taper off at about 38.0 feet per second. And they don't really change a whole heck of a lot after that. So what we can conclude, what would we estimate the speed of our object is at t equals 1 second? We would estimate that it's going to be about 38 feet per second. That's where our average speeds taper off with these smaller and smaller time intervals.